You can begin when you're ready.
Good morning, gentlemen. I am Hamid today. Over the last 12 weeks, I have been reading and trying to understand a growing problem in Svalbard, which is the ocean acidification. Today, in my presentation, I hope to classify or introduce the factors that contribute to high rates of acidification in Svalbard and propose the solution, which is introducing the underwater turbine. I will not dig into some technical engineering details. Let's start by taking a look into the Svalbard context. Svalbard is a remote archipelago located in the half between Norway and the North Pole. Svalbard, due to its location, it's suffers from harsh winter, which strengthens the demands on the energy, and it becomes a critical for survival. However, in Svalbard, the main source of energy is the fossil fuel imported. Fossil fuel, generating energy from fossil fuel, leaves us with a massive carbon footprint. This carbon footprint interacts to form a chemical phenomenon known as ocean acidification. Based on Ms. Grossman figure, we can see when the communities start to generate energy, they release a massive carbon dioxide. This massive carbon dioxide starts to react with the water and form the carbonic acid. This carbonic acid starts to reduce the hydrogen number of the water and start to make it more acidic. This acidization make the environment start to dissolve the shells of the organism that build the system or build the marine ecosystem. Moving to the factors that make the acidification problem in Svalbard, let's start by Mr. Kui and the others. Their research conclude that the low temperature is a great or a significant factor that contribute to the amount of carbon dioxide that absorbed. As the temperature goes low, the amount of absorption increases. Also, the imported diesel. Svalbard cannot extract the diesel locally, so they have to get their diesel from a mainland over 1,000 kilometers. This travel shipment results in another source of carbon dioxide as the shipment itself starts to get its energy by burning the diesel itself. Third, and the final and the last reason is the tourism increase. As the tourism increase, the people increase and the demand on electricity and heating increase, which the energy and the fossil fuel demand will increase eventually. Moving to the solution, which is the underwater turbine that I propose, it works similar to the wind turbine as we can see from the picture. The main difference that the fluid that rotates the blades is changed. Instead of air in the wind turbine, it will become water in the underwater turbine. We work on the same principle, which is converting the kinetic energy into clean electricity with zero emissions. However, according to Gwilly and BBU, the underwater turbine has a great advantage over the other clean energy sources, that it can be predictable based on the motion of currents. Moving to the implementation of the solution and the result of it, it will kill the need for diesel shipment, as it will be a local source of energy. The Svalbard community will not have to import any diesel shipment anymore. Second, it can solve the expansion future needs, as it's scalable and reused, and the modular the designed modular for underwater turbines can be reused again. According to the International Renewable Energy Agency in the United States, the modern the module of underwater turbines produce around 1.5 megawatts of per unit. However, this solution is not perfect solution. There are some technical challenges with it. The main technical that I will focus on it is the corrosion. The corrosion, the metal that make the blades, it's the standard metal that the underwater turbines are formed of, is start to react with the water and start to reduce the lifespan of it. Moreover, this is more concern at Svalbard as the water start to be more acidic. The metal start to react with the carbonic acid and start to shortage its lifespan. According to the water power technology office in the United States, they have found the solution for this problem, which is the thermoplastic blades. To form the blades from thermoplastic instead of the standard metal. The thermoplastic has the resistance to avoid the reaction with the chemical component. Let's conclude. In the conclusion, the underwater turbines shows that it's an alternative for the fossil fuel. It's ensure the independence for Svalbard energy, and it's, and most importantly, protect the marine environment as it will not produce any carbon dioxide. In order to optimize the beneficial of this solution, I advise the energy agency in Svalbard and the project designer team to adopt the axial flow turbines as they can capture currents with high velocity, and to use the thermoplastic as they can resist to the chemical state of the water in Svalbard. And this is my reference, and thank you.
Thank you, Mohammed. I'm curious, why did you choose this context? Why did you choose Sweden, basically? Or sorry, where is Svalbard?
Svalbard, not in Sweden, it's Norway.
Norway, sorry.
Yes.
Why did you choose?
Because it's, I am from Saudi Arabia, and Saudi Arabia is the leading production of oil. And oil is a source of diesel and fossil fuel, which have lots of impact on the environment in other worlds, in other areas in the world. And to strengthen my country economy, I should find the weakness of the current production of the oil and start to know it and to learn about it. And choosing Svalbard and the context of ocean acidification helped me to do so.
Okay, thank you. All right, and Mohammed, you're applying for an electrical engineering position with Aspen Tech?
Yes.
Is that correct? Tell me, how do you feel you can contribute to Aspen Tech?
I can contribute to Aspen Tech by increase the adoption or accelerate the adoption of the assist project management or assist performance management. As I have been finished lots of courses in KFUPM in introduction to AI, and I have a constraint, concentration on the system management. It will enable me with the ability to help in providing Aspen Tech with the ability to enhance its reputation in the market among its competition like Honeywell, for example.
Okay, thank you very much. Oh, I've already got it.